The reason for this video will be explained in the next video, but first let's just get through the information, learn the theory, and then we can move on to the next video and apply it. Okay, so what we're going to talk about is coordinate systems. I've kind of quietly already been using one of them. Let's spend some time defining what it is, and then we're going to have to move on and learn another one, and there's a good reason for it that we'll get to later. Okay, what is a coordinate system? A coordinate system is in this case it's two-dimensional. There could be three-dimensional coordinate systems too. We're not going to get to that detail. We don't need to. Okay, for our purposes, two-dimensional plotting method. Okay, so we're going to create some kind of a method, some kind of a grid-like system in order to do some plotting. Okay, that might sound kind of cryptic, but let's get into the two different types that we're going to learn about. Okay, the first one is called the polar coordinate system. And this is the one that I've already been using. Okay, I haven't really defined it, but I have been working within this coordinate system. The other one is referred to as the Cartesian or rectangular coordinate system. Okay, this is a new one. It'll be very familiar to you. You may recognize that term, you may not, but as soon as I start explaining what it is, you'll say, oh yeah, I've seen that before. Okay, it's very different than what we've been doing so far, but it has a very important function why we need to learn about it. Okay, so let's back up a step and begin at the beginning. So the polar coordinate system. The polar coordinate system uses a radial coordinate and an angular coordinate. So, well, let's just go with this. We've talked about a vector, and we said that a vector has magnitude and direction. And that's what these two coordinates are. Okay, the radial coordinate is the magnitude, okay, the length of the vector, okay, and the angular coordinate is about the direction of that particular vector. Okay, everything relating back to the horizontal to the right. So let's look at that. So the polar coordinate system looks like this. Okay, and we can see why they would call this the polar coordinate system, because this looks like a compass. We have a north pole on top, or south pole on the bottom, west and east. Okay, looks like a compass. So that's the reason for the name. But to identify these angular coordinates, the direction of the vector, okay, we're going to use degrees, just like we've already been doing. Okay, we've already seen this. All right, now I'm just going back and defining it. So 0 degrees, the start point, will always be this horizontal to the right. Okay, this is where we begin. That's 0 degrees. Okay. Forward rotation is in a counterclockwise direction, which means the north pole up here is the coordinate at 90 degrees. Over here, west pole, this is 180 degrees. And the south pole is 270 degrees, which gets us to 360 degrees, which is also our 0 degrees. That's our start-finish line. Okay? So that's how we get our angular coordinate. That's how we identify the direction of our vector. Okay, now let's place a vector in here. So, and then these circles, of course, allow us to identify the magnitude of the vector. So this would be 1 and 2 and 3. So if I placed a vector right there. Okay, and let's say that's 60 degrees. Okay, then the way I would express that vector is it's 3, that's its magnitude, in the direction of, with an angle of 60 degrees. Okay, so 3, angle 60 is how we identify that particular vector. Okay, so that is kind of what we've already been doing. So I want to move on and talk about the other coordinate system. I squeezed it in there. Okay, the rectangular coordinate system, let's start with the very same beginning. Okay, but now we're going to look at this very differently. The rectangular coordinate system is built on what we call an x, y plane. Okay, and so the x value is our horizontal line right here. Okay, and so this is graduated like this. Okay, and then this is the y-plane here. And again, it's graduated this way. Okay, now this point in the very middle is what we call the origin. Okay, and the origin is at the point where x equals 0 and y equals 0. Okay, so the xy plane, it's always expressed x, y. And so down here we would put 0, 0. That is the coordinate of the origin right here, because x equals 0 and y equals 0. Okay, but let's plot a point 3, 2. Okay, what that means is that the x value, the x-axis, has a value of 3. So we're going to count out from 0, 1, 2, 3. So there's the x value of 3. And if the y value is 2, then it's going to be 1, 2. So we come up from the x value of 3 and across from the y value of 2. And we establish a point right there that we call 3, 2. Okay? Now what this coordinate system has that the polar coordinate system does not is negative values. Okay? The other coordinate system, we simply express the angle from the 0 degrees and we work our way around. Okay? In the polar coordinate system, however, okay, in this first 90 degrees, if you will, okay, going back to the polar coordinate system where this is 0 and this is 90, within this first 90 degrees, both values are positive. Okay? You can see that we've broken this up into 4 quadrants, and we're going to call this quadrant 1. And in quadrant 1, both the x value and the y value are positive. Okay? But let's now look for the point minus 2, 5. Minus 2, 5. Let's see if we can find that point. I'm going to change colors. So the x value is now negative 2. So from the origin, we're going to come back to the left, 1, 2. There's minus 2 right there. And then we're going to go the y value of 5. So it's up this way, 1, 2, 3, 4. Oh, I didn't even draw the 5th one. It's up here somewhere. And there is the point minus 2, 5. Okay? And we refer to this as quadrant 2. So in quadrant 2, you will have a negative x value and a positive y value. Okay? Let's move on. Let's pick a point. Negative 3, negative 3. Let's see if we can find that point. So we're still coming backwards to the left from the origin on the x-axis. 1, 2, 3. So we're over here. But now we have a negative y value, so we're going to be going down from the origin on the y-axis, 1, 2, 3. And so we're going to end up right there. And so this is the point -3, -3. Okay, and we are going to call this the third quadrant. 1, 2, 3. That's quadrant 3. So in quadrant 3, both the x value and the y value will be negative. Okay, and finally, do I have one more color? I should, but I don't see any. Well, let's go back to green again. Let's see. Let's try 3 and -4. Okay, so once again we have a positive x value, so we're moving forward from the origin to the right. 1, 2, 3. And we're going to go -4 for the y value. So again, we're going down on the y-axis. 1, 2, 3, 4. So we have a 4, and we have a 3, and we land right there for 3 and -4. Okay, and so this is the fourth quadrant. And in the fourth quadrant, once again, our x value is positive. We are moving to the right of the origin, okay, but our y value is still negative. We're moving down from the origin, okay? So that is the polar coordinate system, and we are going to put this to good use, and I think I will save that conversation for the next video. That is going to conclude this one. I'm trying to keep them all short. I know there's lots of them, but if they're all short, it's not too painful.